everyone, Chadwick Strange here. I'm head of product at SKALE Labs. Welcome to a new series called Network Updates. We're trying to refresh, create some more community updates. So this will be the first of a series kicking off. This will be the first one. And going forward, we should have some regular cadence where I'll be speaking about what has happened over the past month, give some updates around inner workings of the current team, inner workings of product, and what has the SKALE Network community been busy on. So today I'm going to start off with those updates and kind of guide you through that. And then I'm going to end with a demonstration. So I recently presented at ETH New York. It was an amazing hackathon, amazing locations. Shout out to ETH Global team. They're doing such an incredible job with those hackathons. I had a presentation that had a little bit of a hiccup at the end. So I wanted to rekindle and pick off and show everyone that demo because I think it's a really fascinating technology and really shows how powerful skill chains are. So we'll end with that. And so let's get started. The month of June has been incredibly busy. The team has been very busy, not per se developing features, but fixing at least the developer aspect, making things easier for developers to onboard. We have a whole set of toolings that developers are using. Reverse proxy, which is a load balancer to basically send transactions to scale chains. The team's been working on improving the performance and throughput of that, going through design iterations of that. We've also been working on fixing bugs, tuning the performance of scale chains that have already launched, as well as tweaking some of the end-to-end testing that we're doing. Besides that, we've been very busy deploying scale chains. June, I think we deployed maybe around 8 scale chains. This is on top of the other scale chains that have already been deployed. Currently, there's over maybe 24 scale chains that are live now on production mainnet, along with probably a little over a dozen chains on our staging network, a dozen chains on the SKALE QA network. Again, the staging and QA network is what the internal teams use to manage onboard different customers, perform tests, perform demonstrations, and of course the production chains that are arguably run in a decentralized fashion by SKALE Manager on Ethereum and the SKALE network community of validators and node operators. So again, scale chains, given the early stage of the network, it's not like flipping a switch and letting it rip. Arguably it is. It is a transaction that is conducted to basically build or basically provision a skill chain from the network. But there's a lot of QA activity, a lot of engineering and monitoring that the core team is doing to be sure that the validator node operators are operating effectively and the skill chains are operating at performance as they're being provided for SKALE network partners to build on top of. So it's been incredibly great, incredibly busy month getting these skill chains launched, getting them in the hands of partners who are actively building. And then these partners are just not only taking the skill chains themselves, but also learning the nuances, all the great complexity, or not great complexity, but all the nuances of degrees of freedom that developers now have when using a skill chain. Again, there's so much configuration that can be done on the skill chain side, file storage side, the interchain messaging agent, which is the bridge. There's a lot of configurations options there, as well as the permissions that you can set up or multi-sig those different permission systems. We had one community member basically so excited about all these multi-sig or all these permission roles that they've been actively working on creating a user interface as well as a script to help new partners once they get a provision skill chain to them to be able to navigate all the various roles, the granular roles that can be set up, all the configuration options that can be tailored for each Dapp in each Dapp community that the partners build. This has been super exciting, not only for skill chains that are Dapp-specific, but also these sort of ecosystem skill chains that are called scale hubs, like Europa, where the chain is shared amongst many stakeholders or partners who are building liquidity on-ramps and different dApps that share a skill chain. And then they can basically multi-sig off different permission layers such that the community that runs and operates and deploys on that chain can coordinate together to set up the chain and whatnot. So that's been a very busy month as a whole. SKALE Labs core team also supported 2 hackathons, the Graph Hackathon in SF, as well as NFT NYC, or rather the hackathon at the end of that, ETH New York. It was incredible, really great experience. I know earlier today or yesterday, Thursday this week, there was a Twitter Spaces where John, one of our senior solutions engineers who was there at the hackathon, was talking or presenting at Twitter Spaces, presenting some of the teams that won SKALE bounty rewards. So it was an incredible hackathon, incredible job by this ETH Global team. Hackathons are always busy for the core team to support. It was really great to work with developers and the newest tooling and getting them onboarded onto SKALE and seeing what technologies they could build on top of SKALE chains. So that's it. As a whole, we've got a bunch of work coming up. We have a lot of roadmap items that the internal team is sorting through to figure out how we prioritize next releases, as well as a bunch more SKALE chains that will go live in the next few weeks. So that's in a nutshell. What I'm going to do now is actually transition and talk about the demo that was presented at ETH New York. It's actually a second iteration of a demo that was presented at the Graph Hackathon by our Director of Solutions Engineering, Ebru. She made a Dapp that would basically mint ERC 721 NFTs using this really cool artwork and using a graph node, and showcasing what it means to really mint live on a SKALE chain many NFTs in a gasless manner. So she demonstrated on stage that with a script that would basically mint hundreds of NFTs live on a SKALE chain. And it makes use of a new feature called multi-transaction mode, where you can basically queue up tons of transactions being sent to the SKALE chain. The SKALE chain will just start ripping through those transactions, minting NFTs without any gas cost. And then she also tied in the graph node to basically index the events to track different mint events and whatnot. And I believe these NFTs during that hackathon were actually stored on file storage on the SKALE chain itself, which is available on every single SKALE chain. It's a native file storage layer where you can store JSON files that the NFT points to. In that function, the token URI, which points to the JSON file, which contains key value pairs that might display certain properties of NFTs, as well as different pointers to different files to actually show the visual asset of the NFT. And again, you can store that natively on the SKALE chain without having to use another or a separate file storage network. So Ebru and I collaborated. We wanted to take this a little bit further. There's something that I've been reading up on and just observing in the Ethereum community. I guess you'd call it a movement or just a lot of interest around what is called on-chain SVGs, which I find really fascinating. It's basically taking the token URI, which can store data, not just a pointer to a file, but it can actually store encoded data as a data URI that can actually be rendered within a browser. And what kind of data can it store? Actually, a bunch of different kinds of data. For example, SVGs, which is a graphical format that a lot of developers or designers use to make high quality vector-based graphics. So if you've seen, for those of you who might not be familiar, if you've seen a very high quality photo or like a logo rather, a lot of those are stored in SVG, which is really vector resolution, like infinite resolution of these graphics. On SVGs can be combined. First, what is an SVG? It can define a certain geometric shape or a line or something like that. And it can be combined together to actually create an image, or even very complex SVGs that can actually render something that would look exactly like a website with a button and whatnot. So these on-chain SVGs are really special because within the Solidity code, during the mint function, you can seed the mint function with a random number generator or with some randomness that affects maybe part of the SVG component, such as like the width of a circle or the color of a circle. And you can store this on-chain within the contract itself, which is really cool, and I'll show that in just a second. So when instead of actually going to the token URI and getting the link that points to the asset, you can actually take the token URI, which is an encoded piece of data, put it directly in the browser and render the image live. And this way you store the image natively in the contract on chain. It doesn't exist anywhere else, it's totally on chain. I find that very, very cool and very fascinating. Of course, it makes the gas consumption of those contracts enormous, depending on the size of SVG that you're encoding. But we got together and we said, hey, let's take your early iteration and move it towards on-chain SVG. And let's demonstrate actually writing a script that actually mints individual ERC-721s in sequence with different token IDs and use a random number generator to affect the SVG and display this natively in the browser. This way we show high gas consumption NFTs that can be minted for free on SKALE. We can show how quickly you can mint on SKALE, and also make use of a new feature called random number generator, which makes use of SKALE's architecture of BLS threshold signatures to generate the entropy to drive a really solid or true random number available for developers to help drive game features or game design or different graphical elements of designing Solidity apps or games and whatnot. So what this looks like, I'm going to kind of jump around for a second. Let's go here. So this is the contract Abru created called Strange Token. It's pulling in OpenZeppelin's ERC-721 library. And I'm just going to kind of skip here. It's roughly boilerplate ERC-721 with a key couple features. We're pulling in some SVG items here. Actually right here, is the code needed for Dapp developers or partners on SKALE chains to basically pull in a random number generator from the current block. So again, this is copy and pasted code from the documentation portal, which is basically using some assembly to hit a very special precompile contract at this address. And that precompile actually gets the signatures of the current block. And these signatures are, again, there's signature shares from 16 randomly selected nodes that are supporting the SKALE chain. And each of those nodes are signing the block, and using BLS threshold cryptography, each of those individual signatures can be glued together to create a final signature share of the current block. And there's no way that any one node can influence that resulting signature, which makes it a really solid source of entropy. So it's grabbing those signature shares of the current block, applying a hash to it, and that's returning this into a bytes 32 format. And then we're here in this function, we're constructing the token URI, which is creating this encoding of this data field, which will tell the browser this is data. It's the type of data. It's an image stored in SVG, and it's encoded in base 64. And after this will be a jumble of different characters, which is basically a representation of here, this generate SVG function. So if you look in here, it's using the get random function, and it's actually it's transforming bytes 32 into a random number integer, and we're building an SVG here. So this SVG, think of this is like a graphical canvas where we're displaying the height and width of the canvas, and we're designing our first graphical element, a circle. And so we're defining different elements of the circle, like the radius and the ratio of height to width of the circle, defining a black stroke of the line that outlines the circle with a width of 3 and a fill. And if you can see here, each of these elements of the circle are being randomized to a certain extent with the getRandom function. And we're not just doing one circle, we're doing 3 circles. So a circle here and a circle here. And we're all wrapping this into an SVG tag, which can be natively displayed in the browser. So this is a huge chunk of data. Solidity developers are very well aware that adding in maybe 100 circles would be so gas prohibitive on certain chains. On SKALE, there's really there is a slight upper limit. There's 160 million block gas limit on SKALE chain blocks. So you could really pack a lot in here. So again, this is just a demonstration using 3 circles wrapped together in a big data URI set. So this will be encoded in base64 and appended after here. And I'm going to jump over to another screen here. Here's a little terminal window. In here, I have this Strange token. Again, this is available at the SKALE network GitHub repository. Under SKALE Demo, you'll be able to see this demonstration, these scripts. And what I'm going to do is I'm going to run this script called mint. It's going to basically iterate through and increment those token IDs and mint live on a SKALE chain. We're not going to do 1,000, but we are going to do 100. We're going to see that right now. So I'm going to hit this. And right now that's using Web3 to basically connect with a live SKALE chain. And that SKALE chain has multi-transaction mode operating. And now it's basically queuing transactions. Those transactions are being formed into blocks by those nodes. Each of those blocks are being signed by BLS threshold signatures. We're seeing a bunch of output of the token IDs that are being incremented along with the transaction hashes. And again, it's minting, going to the next one, minting, going to the next one, and it's throwing this all onto the SKALE chain itself. We chose specifically ERC 721 so that we could show that incremental mint as opposed to 1155, where you can do batch mint, just to sort of force a little bit more load to the SKALE chain itself. So there we go, 100 NFTs minted with no gas whatsoever. So let's take a look at this. The last token ID minted was 801. So let me patch right back over here to Remix. So I'm using Remix, I'm using injected Web3, I'm connected via MetaMask to the SKALE chain. Here's my account. I already have loaded the deployed contract onto the SKALE chain. And here I can access all the functions, just as any Remix developer knows, you can access all the functions and calls on the deployed contract. So I'm going to pull up a token URI and let's take a look at this. So 801, that was the last token URI that was done. So here you can see a string, it's chain data, image, SVG, all that sort of boilerplate in that function to generate an SVG. And this base64 encoding, which is the encoding of that SVG data. So the cool thing with browsers is you can natively show this in the browser. So I'm going to hit a new tab here and hit enter, and then boom, here are my 3 circles. The browser is natively rendering this data, which is stored on the contract on a SKALE chain. We can go back here and we can pull up another mint, say let's do 601. Actually, I did this earlier today. So I'm pulling this up and let's see what this looks like. Boom, another rendering of some circles. So again, this is just demonstration purposes, but this shows that you can really pack a lot on a SKALE chain. You can mint hundreds of NFTs with 0 cost gas. You can use complex things like generating SVGs. You can make use of the random number generator to help drive some nuances or like seeding or some randomization to the graphics that are being created. And instead of actually creating a script off chain that generates an image or a punk or something like that, that is then uploaded as a file, now developers, well not now, but developers have been generating these on chain, but now there's no more constraints. You can do this on SKALE, gas free. And roughly, I forget what the last metric was, each mint of these on-chain SVGs was maybe around 500 to 600,000 gas units. So as you can imagine, doing 100 of these could be very expensive. A million would be cost prohibitive of any business model to do this, but on SKALE, you can do this. So again, we'll wrap up. So today we cover what happened in June. The team has been busy fine-tuning SKALE chains, fine-tuning all the developer tooling that's supporting partners building on SKALE. Been busy deploying additional SKALE chains to the network. There's currently over 24 SKALE chains live on, or production SKALE chains that are live. The team's been busy supporting different hackathons, supporting community members who are now building on top of SKALE chains or building for the SKALE network in the community to help people onboard and help people use all the great features that are on a SKALE chain itself. And then we covered a demo of seeing how on-chain SVGs work on SKALE. And again, this is nothing different than what you do on Ethereum, but making great use or leverage of the gasless nature of scale chains, and using the random number generator to generate some randomness to those on-chain SVGs. And we minted 100 of them live on a scale chain, queued up and basically hitting the scale chain one after the other. So hope you'd enjoy this. We'll meet again for the next one. I'm excited to kick this off. Hope you enjoyed it. Stay tuned. Ciao.